All right, guys, so we're on to the last section, and that is something called compounded continuously, where the amount in your account equals, and now we have a new equation, PE raised to the R times T. So one of the things I want to point out is we have all these variables, but E is actually not a variable. E is a number. So you know how like pi is 3.14? So we had like pi equals 3.1415, you know, dot, 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 9, 14159265535. I think it's that. All right, so I could continue, but we only have so much time right now. So we've got pi, and then another constant is something called E. And E is actually equal to a number, which is 2.7182818. Okay, so E is actually a number. So just like if I had P pi to the RT, we have PE to the RT. So E is actually equal to 2.718. But we're going to use that E button on our calculator. So one of the things before I start fully, you want to find the E button on your calculator. Now the E button on your calculator, you're going to look for the ln on your calculator, or it could be lowercase ln. Usually E is connected with that. So if you look on your calculator and you hit the second ln button, that would bring up the E. So for most calculators, the TI, Texas Instrument ones, if you hit second ln, that'll bring up your E. All right, so if you do the second button and then hit ln, that'll bring up E, and then either it'll go to the exponent or it'll be like this, E raised to the, and it'll open the parenthesis, okay? So depending on your calculator, you might have to play around with it and see which one works the best way. Some of you might have to do the exponent part first and then hit the E button. It kind of depends on what calculator you have. All right, so first thing, for compounded continuously, we have the amount in your account equals PE to the RT. All right, so you deposit $10,000 in an account. So that's still the same idea as last time. 10,000 is my principal, that's my starting amount. My annual interest rate, so the R is equal to 0.04, move that decimal point to the left too. And then my time, T, equals 3. And then we're going to go ahead and fill those into my equation. So A equals P, which is 10,000, E, which is a number, raised to the R times T. So 0.04 times T, which is 3. All right, so now we're going to try this on the calculator and see if you guys got this. So I'm going to do the E raised to the first because we want to do the exponent part first. So E raised to the 0.04 times 3. If I have something like this up here, you want to make sure that you close those parentheses around the whatever times whatever. So we're going to go ahead and do that, hit enter, and then you're going to multiply that by 10,000. So you should get, hopefully if you type this into your calculator correctly, you get $11,274.97. Okay, so it's a matter of just finding that E button on your calculator. So let's try the next one. You deposit $4,000 into an account, so that's my principal, $4,000 is what I start out with. And then my annual interest rate, so R equals, move that decimal point left to 0.015. Determine the amount after T equals 25 years. So we go ahead and fill that in. A equals P, which is 4,000. E, which is going to be a button on our calculator, raised to the R, 0.015 times 25. So we're going to go ahead and do that first. So we do second ln to bring up the E. 0.015 times 25 times 4,000. And I get my amount in my account after 25 years is going to be $5,819.97. Be careful with that rounding, guys. 5 or more, you round up. So the cents, if you look past the one past the cents, you determine if you have to round that number up or down. Okay? All right, next one. You deposit $200,000. Whoa, I wish I had that to deposit. $200,000. Wouldn't that be nice? Into an account that earns an annual interest rate, R equals 0.078. And it's compounded continuously after 5 years, T equals 5. So we're going to go ahead and fill that in. A equals P, 200,000. E raised to the R times T, so 0.078 times 5. Okay, so we're going to go ahead and take our calculators, and we're going to do second ln to bring up that E. 0.078 times 5. And then we multiply that by 200,000. Make sure you have the right number of zeros. It's a lot of zeros in there. So equals $295,396.16. All right, so after 5 years, if you started out with 200,000 on interest alone, you would have 295,000. You almost have 100,000 more. So that's the power of interest, guys. All right, so now if we scroll all the way back up to the beginning where we had compounded continuously, A equals, and we use our amount that we were given originally, which is 5,000. E to the, now I got to recap, rate is 0.06 and time is 10. So RT is going to be 0.06 times time, which is 10. So it's going to be second ln to bring up that E, 0.06 times 10. And then we multiply that by 5,000. So if we use compounded continuously, the amount in my account after 10 years is going to be $9,110.59. So it's really, really close to daily, guys, because when you think about it, continuously, compounding continuously, that means like every second of the day, and compounded daily, those are going to be pretty close because compounded wise, that's like, you know, the closest thing. So compounded daily is comparable to compounded continuously versus compounded annually. It's going to be a lot less. Okay, and that's it for this one.